Welcome to topic number 25 in Richard James Mathematics Resources, completing the square. The process of completing the square in itself is not very difficult. The difficulties that are usually encountered have to do with manipulating the fractions and negative numbers when they are encountered. Students fail to get the correct answer because they do not remember the negative coefficient of x squared, that the coefficient is not equal to 1, or that a fraction is to be introduced and properly manipulated. In order that you do not fall into the category of the inefficient completers of the square, take note of the fractions and negatives. The result of completing the square can prove to be very useful when trying to sketch a curve, determining the maximum point on a curve and where it exists. It may also be used to solve a quadratic equation. Take note of the steps and the different variations in potential problems, and completing the square will cease to be a headache forever. Now we are going to be looking at the form that the answer is supposed to be given in when we are completing the square. When completing the square, we desire to convert a quadratic expression with general form. So the quadratic expression will have the form like that. You should have been familiar with the expression and the meaning of the A, B, and C from previous chapters. One of them is factorization and the other is solution of quadratic equations. Because common letters are used in the form for the completed square, they will be replaced by capital letters at this stage. So we're going to replace those with capital letters. When completing the square, the quadratic expression is written in the form, two forms. One, we have here A, and in brackets we have x plus b, then all squared. So x plus b is all squared minus some number. Or it might be that the number is given first and then the square is given after. Of course, minus a and x plus b all squared. So a is being multiplied by x plus b all squared as we have it right over here. But we are going to still say what they are. A is the coefficient of x squared and comes straight from the initial expression. In the habit of placing a negative at the back and a positive at the front, the answer may be reversed as shown in the second expression here, and that is where we find that the coefficient of x squared is negative. We try to write it in this form. The value of b may be positive or negative. It is not necessary to indicate a positive sign because, as you have learned before, we can add a positive or negative quantity. The value of k will be a combination of the initial constant c, this one that we have here, the initial constant c, and the adjustment that is made in order that the expression in the bracket will be a perfect square. Now when you get a quadratic expression, it is not going to be necessarily a perfect square. To complete the square on such an expression, it is important that there is an adjustment that is going to be made, and after making the adjustment is basically a number that is going to be added or subtracted in the end. So it will be a combination of that number that you are going to use in order to get the expression to be a perfect square and the pure number that was there before. And that we'll see how it works itself out as we go along. So let us consider just one of the expressions, that one. The first one. The most significant component of the expression is the perfect square. That is why at the end we can say we have completed the square. So that is why that is the most important part of the completed square. And of course, let us look at the perfect square. Remember this? A plus b all squared. The first one squared, twice the first times the second one squared. That you will see coming. You have seen that before when we were doing factorization, so we are quite familiar with the form. And of course, we expanded perfect squares as we move on to other topic which required us to do that. Reverse the expression, placing the trinomial first in the same order as your typical problem. So usually when you get a problem to complete the square on, the trinomial is going to be first. So the trinomial is going to be right here, and then the square is on the right hand side. Now we're going to take a look at a trinomial that we desire to write in the form of a perfect square. So we have a trinomial here, and we're going to write it in the form of a perfect square, which is somewhat similar to what we have here, because on this side we have a trinomial, this side we have a trinomial, and on the right hand side we have a square and a square. So we're going to use this as our guide to see if we can complete the square. Of course, we have a squared, and that is the same thing. We have x squared right here. So of course there's no doubt that in the expression a is equal to x. So we don't have a problem. So where we have a here, we may put x there also. Right. Now the middle term is 2ab. But we know what a is already. So this term here, 2ab, is equal to 12x. But what is a? A is x. So we're going to say that 2ab is equal to 12x. So 12x is equal to 2ab. And of course, what do we know? That a is equal to x. So because a is equal to x, that means they can be cancelled from the expression. Right, so there we have it. 2ab is equal to 12x, and the a is equal to x, so they may be cancelled from the expression. So we're going to have in the next step, 2b is equal to 12. So 2b is equal to 12. 2b is equal to 12. Do not forget that what we need right here is b squared. But it's 2b, so we have 2b, and we need to carve out b squared from that. Now 2b is equal to 12, therefore b is equal to 12 divided by 2. So never forget that fact. Never forget the fact that the coefficient of x is 12, and that is divided by 2 in order to find the value of b. So we're going to find the value of b. So 2b is equal to 12. So b is equal to 12 divided by 2. And of course, when we are completing the square, we are going to be taking half of the middle coefficient, or we're going to say the middle coefficient divided by 2, which basically is the same thing. This is done because it is for you to remember why it was done in the first place, in order to figure out why it is going to be done at that stage. It is going to be done because the middle term, as we see, was what? 2ab is equal to 12x. But a is equal to x. So 2b is equal to 12. Right, so here we have it, 2b is equal to 12. So in order to find b, we have to take half of 12, which is just a matter of transposition, dividing by 2 on the other side, because we have b multiplied by 2 here. So we divide by 2 on the other side. Right, so b is equal to 6. There you go. All right. But let's see if having a 6 here is the sum total of what we need to have. Remember that b is equal to 6, right there. Square 6 and we get 36, not 15. So if we square 6, when we are writing this as the perfect square, x squared goes there, no problem. 2 times x times 6 is 12x, that's correct. So we have these two are all right, perfect. So we need to know to have this as a square, because we have here 6. 6 is right there. When we square 6, we get 36, not 15. Therefore, there's an adjustment that needs to be made in order that the two expressions may be equal. So in order that what we have here is equal to here, do not forget that this is the original. So what we have on this side must be equal to what we have on this side. We know that this part is okay already, and we know that the 12x part is already perfect. So the only problem that we have is that if we were just to expand this that we have here, that this number would not be 15, it would be 36. So we'll have to shave off some of the 36 to get it down to 15, and that is the adjustment that we really need to make. Both sides of the expression are required to be equal. What do we add to 36 to make it equal to 15? So 36 plus n is equal to 15. Of course, a simple linear equation, and then n is equal to negative 21. The negative 21 will take its place in the completed square. Right? Because if we were to expand this, we'd get exactly what we have on the left-hand side, with the exception that we'd get 36 instead of 15. So in order that we might get the 15, we'll have to take away 21, because inside here we have a potential 36. This, like most mathematical processes, might not find its place in a countable part of your brain quite easily. Things that do that are usually bad for your health, physically and spiritually. This will take some amount of rehearsing. However, this is not what you rehearse. These steps are outlined in detail in order that while completing the square, students will understand why half of the middle coefficient is taken, and also why an adjustment has to be finally made to the perfect square. So you will not be doing this in completing the square, although students might take a tip from it, or students might approach it in the same way. But I think that the way that I'm going to be presenting to you is also a very good way that we can complete the square, and we'll see that in a minute. So we're going to complete the square on the following expression, which is x squared plus 8x plus 5. In order to do that, what do? We know that we have to have a perfect square. Now, remember that when the adjustment was made recently, in the previous exercise, previous example, the adjustment was made to the last number at the end. So the adjustment was made to this number, potentially to this number. Therefore, what we had before, the x squared and the middle term, those terms are usually unaffected. So those terms are placed in the bracket, and then we try to get the expression in the bracket to be a perfect square. So what do we do then? After placing the first terms in brackets and leaving the other one out, what do? We include a third term which will complete the square. So the third term in the bracket is b squared. This is obtained by taking half of the middle coefficient, which is 8, and squaring the result. And remember that what we did just now. So in order to get this figure here, which is the third term, we took half of 8 and we squared that. So half of 8 is 4. When we square that, we get 16. Now what do we know? All the terms in the second expression have their equal in the third expression. So we have those two expressions there. Notice that we have x squared there. Those are equal. Those are equal. Those are equal. And what? That 16 is added and was not there before. Notice that the 16 was not there before. Now to cause the expression to be equal, it will have to be taken away in the end. So we'll have to take away the 16. So let us do that now. So we subtract 16 there. While the expression that we have in the bracket is a perfect square. So write the answer with the perfect square, and let us do that. We're going to write the answer with the perfect square. What happens? The x is inserted first. So that x is there first. Right? And then what? The next term in the bracket is the square root of 16. The square root of 16 is 4. The sign in the answer is the same sign as the middle coefficient. Right? And of course, at the end, what? 5 minus 16, that is equal to negative 9, and that's all there is to it. Let's see, we are taking another. Of course, we're going to place the first two terms in brackets. Then, as usual, we are going to take half of the middle coefficient and square the result. So what is the middle coefficient? The middle coefficient is negative 16. Half of negative 16 is negative 8. When we square negative 8, we get a positive 64. And notice that everything, those are equal, those also, and that. So the one that was not there before is a positive 64. To get rid of that positive 64, what do? We'll have to take 64 at the end. The expression that we have there is a perfect square. The one inside the bracket is a perfect square. So we're going to write that answer as a perfect square. So the x will go there. And of course, the next term is the square root of 64, which is 8. That is going to go right there. And the middle, the sign of the answer is the same sign as the middle coefficient. So the one that we have there is a negative. Right, so that sign is negative. And of course, 20 minus 64 is equal to a negative 44. And the square has been completed. If all of the expressions were like the first two, completing the square would have been a breeze. The fact is, we have to cater for all of the possible expressions with their signs and coefficients. Never forget anything already presented. So we are not going to forget anything that we have learned already. We are going to keep those things in our minds as we go forward. Now, remember now, the coefficient of x squared must be 1. So when we are going to be completing the square, this coefficient of x squared that we have right there must be equal to 1. So this coefficient of x squared is 1. In order for it to be 1, we have to factor the 3. So we have to take 3 as a common factor. So that we have done. While taking out 3 as a common factor, the 12x is also affected. Because if we keep the 12x and put it right here, when we expand, we're going to get 3 times x squared is 3x squared. And remember that we did not, the 12 was not affected. We put 12x right there, would be 3 12s, 36, and that is not going to be correct. So if we are going to factor the 3 right here, we will have to say 3 into 3x, 3 into 3x squared is x squared, and then 3 into 12x is 4x. Because 3 into 12 is 4. So we have 3 into 12x is 4x. So we have to do that. Then, what do? As usual, we take half of the middle coefficient. The middle coefficient right there is a positive 4. When we take half of 4, we get 2. When we square that, we get 4. So we take half of the middle coefficient and square it. Remember that earlier on, 2b is what we have right there. So the 4x is equal to, the 4 is equal to 2b. So to get b squared, we have to first take half that we can get b, and then we square. So that's what we have. All the terms in the second expression have their equal in the third expression as usual. Usual is the same. What do we have there that was not there before? This 4 right there. So 4 is added and was not there before. So we need to take away the 4. So we naturally will put negative 4. However, it is inside of the bracket that is multiplied by 3. So the overall effect of having a 4 right there inside of the bracket is 12. So we are required to subtract 12 in the end then. So let us do that. Right. And let us write our square. So write the answer with the perfect square. What do? The 3 is there comfortably at the front. The x is going to go there. And then what is the square root of 4? The square root of 4 will go there. And what goes there? The sign of the middle coefficient. And 7 minus 12, that is equal to negative 5. And that's all there is to it. After the 3 is taken as a common factor of the first two terms, take half of the middle coefficient and square it, and that is what we always do. The middle coefficient is 4. So 4 divided by 2 is equal to 2. And when we square 2 again, we get 4. This is the term that completes the perfect square. Remember, everything inside the bracket is multiplied by 3, including the 4 that we have just placed there. So, what do we need to do in the end? So if the initial steps are forgotten, then we need to rehearse them again. So instead of taking away 4 at the end, because the 4 inside the bracket is multiplied by 3, contributing all of 12, we need to subtract all that 12 also. So at the end we subtract 12, and 7 minus 12 is equal to negative 5. Here's another one. Let's see if we can make a prediction. We have 2x squared. We do not need that 2 right there, so we're going to factor that. So by factoring the 2, the negative 20 is going to be affected. So we have to say 2 into 2x squared is x squared, and we have to say 2 into negative 20x is negative 10x. So let's see if that's what we have. Lovely. And then we have a negative 6 there. And what do we do again? From here, we are going to take half of the middle coefficient as usual and square it. What is half of negative 10? Negative 5. Square negative 5, we are going to get a positive 25. And as usual, everything that we have there has its equal again. Let's see if it's everything. Seems to be everything. Not quite. 25 was not there before. So we have to take away the 25 in the end. But that 25 that we have here is multiplied by 2 first. So its overall contribution to the problem is 50. 2 times 25, which is 50. So we subtract 50 in the end. That is what we are going to do. Right. So what do we say now? Write the answer with the perfect square. X squared, so x is going to go there. 25, what is the square root of 25? 5, it goes there. What sign will it have? Same sign as the middle coefficient, so that's going to be a negative sign. And then negative 6 minus 50 is negative 56. That will go right there, and that is our completed square. After the 2 is taken as a common factor of the first 2 terms, take half of the middle coefficient as usual and square it. The middle coefficient is 10, and when we divide that, we get by 2, we get 5. When we square 5, we get 25. This is the third term that completes the perfect square. 25 was not there before and will be subtracted in the end. However, it is inside of the bracket that is multiplied by 2. This is why 50 is subtracted instead. Let's see if we can figure out what to do when the sign is negative. So we have a negative x squared right here. So what do? We factor, of course we know that the negative sign means that the coefficient of x squared is negative 1. But we still may just factor the sign instead of writing negative 1. So there we have it. But say negative 1. Remember now, negative 1 into negative x squared, negative into negative, positive x squared. So negative 1 is going to go into positive 14x. Negative into positive is negative, so that is why we have a negative 14x here. Now, why couldn't we have completed this square with this negative x squared right there? Why? Because there is nothing that we can square to give a negative expression. So that is why we need to factor off that negative 1. So let's see what happens. We are going to progress the same way. Square half of the middle coefficient as usual. So we're going to take half of the middle coefficient, which is negative 7, because half of negative 14 is negative 7. When we square negative 7, we get a positive 49. All the terms in the second expression have their equal, and that is what we always say. That, and of course that. So what was not there before? 49 was not there before. Good. So what do we do with that 49? Now that 49 is inside of the bracket, and what do we have multiplying the bracket? Negative 1, although it is not necessary to put the 1 there. It is a negative 1 that we are multiplying by the 49. So instead of having a 49, we are going to have negative 49. So we need to neutralize that negative 49 by doing what? By adding 49 in the end. So 49 is added and was not there before. However, it is inside of a bracket that is multiplied by negative 1. Negative 1 multiplied by 49 is equal to negative 49. we have introduced a negative 49. So to neutralize it, we need to add 49 at the end. There you go. So, no problem writing down the square now, the perfect square or the completed square. What do we say? The x will go there. Square root of 49 is 7, goes there. And of course, the negative sign will go there. What is 49 plus 4, or 4 plus 49? That is what is required to go there, 53. And of course, we have the one with the negative at the front. So we may reverse the expression in order that the positive component may be placed at the front. So the 53 is placed at the front, and then the negative x minus 7 all squared is next in line. Because of the negative that is before the bracket, all terms in the bracket are negated, including the 49. This is equivalent to subtracting 49 from the entire expression. To compensate for this, 49 will be added. Remember that when the positive term is introduced, we subtract in order to maintain the original expression. So now that we have a negative term that is introduced, we need to add in order to get our original expression. Here we go again. But what do we notice? A negative 3 here. So we are going to factor off that negative 3 and say negative 3 into negative 3x squared will give us x squared, and negative 3 into negative 6x, negative into negative is positive, 3 into 6 is 2, there's nothing to cancel the x, and it goes right back there. Now we're going to take half of the middle coefficient and square it. So half of 2 is 1. Square 1, we get 1. So as usual, all terms are equal with the exception of this one that was not there before. Let's show that it is really a positive one. Now we have this red showing that, causing this to look negative. So let us remove that first. Good. So we are sure that it is positive, so let us place it there again. Good. So what do we notice? That we have this positive one to get rid of. However, it is inside of a bracket, and what is inside the bracket? Inside the bracket that is multiplied by a negative 3. So instead of it being a positive 1, it is negative 3 times 1, it is a negative 3. So we have introduced a negative 3, therefore, in the end, we need to add 3. So we have done that, and let us move to complete the square. Of course, as usual, x goes there. What is the square root of 1? The square root of 1 goes right there. The sign of the middle coefficient goes right there. And 2 plus 3 is equal to 5. Goes right there. And of course, we are going to reverse the expression in order that the positive thing may be placed at the front. And that's what we have. And that's all there is to it. All of the principles involved in completing the square were presented in the first exercise. However, different signs and fractions make the process a little bit tedious. The next slide will present fractions. Maintain the initial principles. Only fractions are new. So we are going to have to manipulate those fractions, and I'm sure that there's no difficult task to it. Good. So we are going to factor off these 2. How did we factor the 2? We are going to do it just like we did before. Say 2 into 2x squared is x squared, and then we're going to say 2 into 3x. However, it does not happen without a remainder. So instead of writing remainder, like we could write 1.5, but when you square 1.5, you are going to get what? 2.25. And if the number or the fractions become more sophisticated, it's going to be more difficult to square the numbers. But when we leave our expressions as fractions, we find that they are easy to square. And that is why we have those written in vulgar fractions, some of which are going to turn out, like this one that we have right here, to be an improper fraction. But we'll just progress in the same way. So the next step, remember, take half of the middle coefficient and square the result. So we're going to take half of this. The middle coefficient is 3 over 2, so we're going to take half of that. And we are going to put that under the microscope to show how it is done. There we go. So we're going to take half of 3 over 2. To take half of something is either we're going to divide it by 2 or we're going to multiply by a half, which is the same thing. So we have 3 over 2, and that is multiplied by a half, and we get 3 over 4. Therefore, we take half of the middle coefficient, we need to square it. So we're going to square 3 over 4. When we square 3, we get 9. When we square 4, we get 16. So 9 over 16 is what we get. Right, so 9 over 16 is what the answer is going to be. Now, we need to take care of this 9 over 16 that was not there before. Remember that when we were completing the square in the other exercises, all of the terms were there except the third one. Has no representative. So we need to get rid of this. So we need to take away 9 over 16. But how do we do that? Remember that we need also to multiply by what we have in front of the bracket. So instead of just moving the 9 over 16, we need to multiply by 2 first before we may subtract. So we need to neutralize the new fraction. However, it is multiplied by the number in front of the bracket, which is 2. So we need to multiply 9 over 16 by 2. Here we are going to do that. 2 multiplied by 9 over 16. 2 is a fraction. What is that fraction? 2 over 1. So to multiply 2 by 9 over 16 is the same thing as multiplying 2 over 1 by 9 over 16. And of course, the 2 will cancel with the 16, like we have it right there. And the answer is 9 over 8. So we are going to subtract 9 over 8 in the end. And that is what we have right there. Now, seriously, we need to do something about this whole number and this 9 over 8 that we have right there. So, of course, x squared, x goes right there. 9 over 16, what is the square root of 9? 3. What is the square root of 16? 4. 3 over 4 goes there. And of course, remember that the sign of the middle coefficient is going to go right there also. Now we need to make this adjustment by doing a calculation. As usual, we have a square root of 9 over 16 also, and of course the middle sign of the middle coefficient is also there. Now, how did we get this 31 over 8 in the end? How did we get that? Let us see. Now, remember that when you have fractions to add our numbers, to add some of them mixed, some of them fraction, if we could get all of the numbers to have the same denominator, we just add the numerator, put the figure over the denominator. And it, of course, applies both to addition and subtraction. Now, to get this 5 to be written as a fraction with the denominator of 8, we say 8, 5, 40, and then we put that 40 over 8. Right? So, we have 40 over 8. So this 5 becomes 40 over 8. Now we're going to take this 40 over 8, which is this 5, is 40 over 8. Of course, if we divide 40 by 8, we are going to get 5. So realize that it's the same thing. Only that it has the same denominator as the 9 over 8, so that the subtraction can take place quite easily. So what do we say then? 40 minus 9 is 31. And that is how we arrive at this 31 over 8. Of course, it might look a bit cumbersome, time-consuming, and all of that, just to put it on the side. But when students are working it out, I don't imagine that they'll want to put it down on the side. I imagine that they'll do it in their minds. So they would say 8, 5, 40 minus 9, 31, 31 over 8. That is what I expect that they'll do in a single step. I'm just putting it there that students are aware of the steps that we have taken. Not that it should take such a long time. The principles are the same. The introduction of fractions only makes it a little tedious. The principles should have been developed from the previous examples. Just apply the additional skills of manipulating the fractions. That's what we are doing. Here's another one. So we're going to factor off the 5 as usual. And what will happen? How do we factor? We factor by saying 5 into 5x squared is x squared, and 5 into negative 6x Because it does not go without leaving a remainder, we just leave it 6x over 5. And here we have the expression shown in detail where we take the common factor outside. Remember that we did that when we were factorizing at the most basic level. We took the common factor outside, then we divide each term by the common factor as usual. So that is why we have this. These will cancel, and of course 6x over 5 will not cancel, so we just leave that as 6x over 5. Right. So we're going to take half of the middle coefficient and square it. So we're going to take half of this middle coefficient, which is 6 over 5. So let's do that. 6 over 5, take half of it. What do we notice? Multiply by a half. Some students might write 6 over 10, which is not wrong, but if the thing can be reduced, reduce it in order that you don't have two large numbers working with. So we say, cancel this, we have 2 will go into both 2 and 6, and then our final result is 3 over 5. So we're going to square 3 over 5. When we square 3 over 5, we just square the 3, we get 9. Square the 5, we get 25. That's all there is to it. So what do we notice now? Our good friend that was not there before comes up every time we are completing the square. So we need to neutralize this, but it is multiplied by 5 first. So what we have, 9 over 25 to be multiplied by 5, that we have right there. What happens? 5 is 5 over 1, and then 5 will cancel into 25, and we'll have 9 over 5. So it's actually 9 over 5 that we need to get rid of. So that is why we subtract 9 over 5 right there. Remember that we need to get rid of this 9 over 25 because it was not there before. So we are going to multiply that 9 over 5 by the 5 that is in front of the bracket. Why do we do that? Because the 5 that is in front of the bracket has to multiply every single term inside the bracket. And then we'll know what is the overall contribution of that fraction, or the effect of it. The effect of it is just 9 over 5, so we subtract 9 over 5. So let us do the fraction part in our mind and show that it can be easily done. So what do we say? 5 7s 35. So we have negative 35 over 5 and negative 9 over 5. When we put them together, we get negative 44 over 5. And that's all there is to it. But I'm still going to show the steps. Here we have our square completed, right? As usual, we know what will go where. We know that the square root of this will go right there. And we know that the middle coefficient, the sign of the middle coefficient, is going to go right there. And then let's see if we have placed that under the microscope, that negative 7 minus 9 over 5, what turns out to be a negative 44 over 5. Do not forget that all we need to do is multiply this 7 by 5. We get 35. So that is 35 over 5. And what happens? We have negative 35 over 5 minus 9 over 5, and that is equal to 44 over 5. Negative 44 over 5. There's another one. Factor off the negative 4 and see what we get. This time we have a negative fraction. So let us see what adjustments need to be made. Let's go. We are going to do it just like how we do our basic factorization. Anything that we take as a common factor has to be divided into the other terms, and that's what we have done. When we do that, the negative 4 cancels the negative 4. We have a positive x squared right there. And what do we have? Negative 7 over negative 4. We imagine that this is going to turn out to be a positive 7x over 4. Lovely. Right there we have it, a positive 7x over 4. And as usual, we are going to progress to take half of the middle coefficient and square it. So let's take half of the middle coefficient. The middle coefficient is 7 over 4. What is half of 7 over 4? 7 over 4 multiplied by 1 over 2. And that, of course, is 7 over 8, multiplying the numerators, multiplying the denominators. And then we are going to square 7 over 8. So we square the 7, we get the 49. Square the 8, we get the 64. That is going to be a whole lot easier than, say, 7 divided by 8 is 0.875. And then after doing that, what do? We attempt to square 0.875. That is going to be more than a mouthful. vulgar fractions turns out to work quite easy. So what do we do now? We need to get rid of this 49 over 64 that was not there before. So what do? We're going to multiply 49 over 64 by 4. So here we have it. Negative 4 to multiply by 49 over 64. And of course, that turns out to be 49 over 16. Of course, the negative sign is also considered. So we have a negative 49 over 16. So in the end, we need to add 49 over 16. This is our new comma to the system that was not there before. We need to get rid of this 49 over 64. But before we can do that, we have to remember that it was multiplied by a negative 4 at first. So we need to see what is overall contribution to the entire problem. A negative 49 over 16. So we're going to add a 49 over 16 right there. Now we need to add these. 9 plus 49 over 16. So we need to say multiply 16 by 9 and put it back over 16. So it is still 9. So if you multiply by 16, then divide by 16, it is the same thing. Only that it is going to be in a form that it causes it to be easier. It causes it to be easy to add to the 49 over 16. But let's see how that, remember that we have x squared goes there. Of course, the square root of 49 over 64 will be placed right there. And the sign will go right there. Same sign as usual. And let's see what, this is what we have. 193 over 16. But let's see how we arrive at that. So we're going to multiply this 9 by 16. Putting that over 16, we're going to get 144 over 16. And when we had 144 plus 49, we're going to get 193. Of course, we're going to turn the expression around, placing the positive quantity at the front as usual. So we finally write the expression with the positive part at the front. Omitting this step does not make it wrong. Including it is just a matter of good manners. The time is just right now for our final example. So we're going to factor off a negative 2 as usual. The x is also going to be affected. So x divided by negative 2 is negative x over 2. And of course, what are we doing with these? Showing our basic factorization. Of course, we're not going to be using a complete factorization because although x is common right here, we're not going to be taking x outside. Taking x outside will mean that we will not have any term in x squared. Hence, we will not be able to factorize. We will not be able to complete the square. So, of course, what do we have? We are going to have a x to be divided by negative 2, so it's going to be a half x or a negative x over 2. After we have that, we need to take half of this middle coefficient and square it. So let's see what we are going to do. Take half of that. What is half of a half? A quarter. Square a quarter. Square 1, we get 1. Square 4, we get 16. So it's actually 1 over 16. Right there. With everything put together, we need to get rid of a 1/8. A negative 1/8 that was not there before. So we're going to do that by adding 1/8. So let's see how we arrive at our negative 1/8. Do not forget that this 1 over 16 that we need to get rid of is being multiplied by a negative 2 first. So we say negative 2 multiplied by 1 over 16, and that gives what? Negative 1 over 8. So because this is present right here, it means that effectively negative 1/8 is introduced. So to neutralize that negative 1/8, we are going to add 1/8 at the end, which is what we have right there. Now, all we need to do before we do that, remember x goes there. And what is the square root of 1/16? The square root of 1 is 1. The square root of 16 is 4. So that's what we have right there. And of course, what will happen with that? Same sign that we have for the middle coefficient goes there. And finally, we have 41 over 8. But how do we have that? How did we get that? Remember, 5 times 8 is 40. So we have 40 over 8. So 40 over 8 plus 1 over 8 is 41 over 8. So 41 over 8 is good to write the negative at the front as usual. So we finally write the expression with the positive part at the front. Omitting this step does not make it wrong. Including it is just a matter of good manners. Now, we have gone through the process of completing the square, and we have gone also through the origin. Now, if we rehearse this slide time and time and again, the ideas in completing the square should be pretty much straightforward at the end.